You're watching Statistics Made Simple with Savita Wilson. In this video, based on control chart for variables, I find solutions to 5 markers based on the mean and range charts. Problem 3. In a palm oil packaging company, the palm oil is filled in tins. Samples of 5 tins are selected at regular intervals. The following data reveals the mean and range of weight of tins. Construct the mean and range chart and comment. So we have the subgroup number from 1 to 6. Then the X bar values are 10, 11, 9.5, 14, 18, 19. And the range, that is R values, are 8, 7, 4, 10, 8, 6. The totals of the means and the ranges are also given respectively as 81 and 42. So let's start with the solution. So be very careful over here. So K stands for the number of samples. So that is K is equal to 6 and the size of each sample is N, which is 5. So starting with the X bar chart, the case is when the process standards are unknown. The 3 sigma control limits are given by CL is equal to X double bar, UCL is equal to X double bar plus A2 R bar, and LCL is equal to X double bar minus A2 R bar. Double bar is calculated using the formula summation X bar divided by K, which is 81 by 6, that is 13.5, and R bar is summation R by K, which is 42 by 6 equal to 7. And when N is equal to 5, from the statistical tables, A2 is 0.729, D4 is 2.282, and D3 is equal to 0. So substituting, we get CL is equal to 13.5, UCL is 13.5 plus 0.729 into 7, which gives us 13.5 plus 5.103. LCL is 13.5 minus 0.729 into 7, which is 13.5 minus 5.103. Therefore, the 3 sigma control limits for the X bar chart are CL is equal to 13.5, UCL is 18.103, and LCL is equal to 8.397. The problem says to construct the mean chart and comment. So we have to draw the graph for this particular problem. On the x-axis, we take the subgroup number or the sample number from 1 to 6, and on the y-axis, we take the quality characteristic, that is the x bar values. So we have to choose an appropriate scale. So I have chosen on the x-axis the subgroup numbers from 1 to 6. On the y-axis, I have taken the scale as 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So please choose an appropriate scale. So look at the X bar values and also look at the CL, UCL and LCL values. Among these, find out the least value and the highest value and then choose the appropriate scale. The heading is the mean chart. The next step is to mark the CL, UCL and LCL. So I have marked the CL at 13.5, UCL at 18.103, which is approximated to 18.1, and LCL similarly I have approximated to 8.3, or it can be 8.4 as well. Then corresponding to each sample value, you have to mark the corresponding mean and then join all these points by straight lines. So you get a line as seen in the graph, which is highlighted in red color. Now you observe that one of the sample values are lying outside the control limits. That is, in this case, we see that it is lying above the UCL. So the conclusion will be Since the sample point corresponding to sample number 6 lies above the UCL, the process is out of statistical control. Let's now construct the R chart. Case 2, when the process standard is unknown, the 3 sigma control limits are given by CL equal to R bar, UCL is D4 R bar, LCL is D3 R bar. So CL is 7 and UCL is 2.282 into 7 and LCL is 0 into 7. Therefore, the final 3 sigma control limits for the R chart are CL is equal to 7, UCL is 15.974 and LCL is equal to 0. To draw the range chart, on the x-axis we take the subgroups from 1 to 6 and on the y-axis we take the different ranges corresponding to each of the samples. So based on the range values given in the problem and the control limits for the R chart, I have chosen an appropriate scale for the y-axis from 0 up to 16. Next, we mark the central line, that is CL, which is equal to 7 as a dark line. The UCL is marked at 15.9, which is a dotted line, and the LCL is marked at the x-axis, which is equal to 0. Then corresponding to each sample, we mark the range, and these are joined by a straight line which is highlighted in blue color. Now, since all the sample points lie within the 3 sigma control limits, we conclude that the process is in statistical control. Problem 4. In a production process, 8 samples of size 4 are collected. Their means and ranges are given below. Obtain the 3 sigma control limits for the mean and range chart. The subgroups are from 1 to 8. Then the corresponding x bar values are 13, 11, 14, 12, 13, 16, 11, 11, and the R values, that is the ranges, are 3, 2, 4, 2, 5, 4, 3 and 2. Now in this question, they have only asked us to find out the control limits and we are not going to draw the control charts. So let's start with the solution. Given k is equal to 8. So remember that k stands for the number of samples and n is the sample size, that is equal to 4. Let's start with the x bar chart. The case will be when the process standards are unknown and the 3 sigma control limits are CL equal to x double bar, UCL is x double bar plus A2 R bar, LCL is x double bar minus A2 R bar. X double bar formula is summation x bar by k, which will be equal to 101 divided by 8, which is 12.625, and R bar is summation r by k, which is 25 by 8, which is 3.125. When n is equal to 4 from the statistical tables, the constants A2 is equal to 0.729, D4 is equal to 2.282 and D3 is equal to 0. Therefore, we get CL equal to 12.625, UCL is 12.625 plus 0.729 into 3.125 and LCL will be 12.625 minus 0.729 into 3.125. On further simplification, the final 3 sigma control limits for the x bar chart are CL is equal to 12.625, UCL is equal to 14.9031, LCL is equal to 10.3469. Second is the R chart. Case again will be when the process standard is unknown. The 3 sigma control limits are given by CL is equal to R bar, UCL is D4 R bar and LCL is D3 R bar. So substituting the value of R bar, we get CL equal to 3.125, UCL is equal to 2.282 into 3.125, LCL is equal to 0 into 3.125. Therefore, the 3 sigma control limits for the R chart are CL equal to 3.125, UCL equal to 7.1313, and LCL is equal to 0. So either the X bar chart or the R chart can be asked as a phi marker. Thank you all for watching. Remember to practice daily because the quality of your practice determines the caliber of your performance. Look out for my next video where I will discuss about control chart for attributes and in particular the D chart or the defectives chart.